Good morning, everyone. Today we are going to dive into Biotonic sort, a parallel sorting algorithm that's especially useful in multi-core and distributed systems. Biotonic sort is a parallel sorting algorithm, a comparison-based sorting algorithm designed for parallel processing. The core idea revolves around Biotonic sequences, which are the sequences that first increase and then decrease, or vice versa. The algorithm works in three phases. First, we create a Biotonic sequences, then recursively divide them, and finally merge them using the Biotonic merge process. Its structure allows efficient use of parallel processors, making it highly scalable. Then sorting networks. To understand Biotonic sort better, we need to talk about sorting networks. These are fixed set of comparison steps that don't depend on input values. The basic component is a comparator which compares two elements and swaps if needed according to the flag that is decreasing or increasing. The performance is measured in terms of depth, how long the chain of dependent comparators is, and the size and total number of comparators used. Then Biotonic sequences. A Biotonic sequence we have already discussed, which is a sequence that either increases or then decreases. For example, 3, 5, 8, 9, 7, 4, 2, 1. It's first increasing, then decreasing. Or vice versa, 8, 5, 2, 1, 4, 7, 9, 10. Here, first sequence is increasing, then it's decreasing. And in Biotonic split, we are dividing the Biotonic sequence in two equal halves. Then what are the steps of Biotonic sort algorithm? Here is the flow of the algorithm. First, we create a Biotonic sequence from our input. Then we perform Biotonic merge. Then merge uses compare and swap operation based on the element index and the comparison distance. That is basically increasing order or decreasing order. With each stage, we reduce disorder until we get a fully sorted output. This hierarchical and structured approach makes it perfect for parallel execution. Then Biotonic sort is performed in stages, like first when we merge, first when we sort, then we merge. So here it is described as following. So these are the stages, these are the steps. So let's discuss with this through code. First, let's visualize the Biotonic sort. See, first Biotonic sequence would be created, then it would be merged to create a Biotonic sort in a sorted order. See how beautifully it's sorted in a ascending order. Now coming to the code part. So these are several functions we use in Biotonic sort. First we use Biotonic sort, then Biotonic merge, and within merge we use Biotonic compare. In Biotonic sort, when we pass first the initial element index, then count, and a direction, that is ascending order or descending order. So when we start with Biotonic sort, we are initializing the first index with 0, because 0-based indexing is used in C++, and the power is basically the size of the array in the form of power of 2. If the size of array is given by user is not in the power of 2, we will use some extra elements or the maximum elements to make it to the size which is in power of 2, because Biotonic sort works well or works good with the power of 2 size array, because it consists recursion and divide and conquer at each step. So let's start Biotonic sort. When we pass index, count, and direction, it would check if the size is less than 1 or greater than 1. If it's greater than 1, then it would divide it into two halves. Then first half would be sorted in ascending order, then second half would go for descending order sort, and then Biotonic merge would be called. We are checking if it's left half and it has a flag of true, then we would compare and sort it into descending order. Else we would sort it into decreasing order, which is being happen through Biotonic compare. Here we are checking if the direction is same as the direction of ascending order, then we won't swap, or if the direction is false and it's already in ascending order, then we would swap so that it would become in descending order. That's how it's happening. Let's run this code. So here 4 steps or step-by-step output has been printed. Like first, it would be called, this Biotonic merge function would be called when the k size is 1. That is, when we have sub-array size of 1, then first it would be called. Then it would go back to the size when k is equal to 2. So it would be better to explain here. See, first we have an array, then it's dividing into 2 halves, 2 equal halves with different flags. Then again it's being divided. Then again here we have k is equal to 1 and count is k equal to 2, and when we divide it further, we will get counting. Here we would with true as flag, and here we would return with false as flag. Now this has true as its flag, so it would go over and then sort it accordingly in ascending or descending order. Since it's already in sorted form and true flag, so it won't be disturbed and it would return as it is. Then it would go for with false for right part of the array. So for 4 3 again it would get divided into 2 equal parts. Here again count is 1, so return back 4 3 is already. So this would go and it would be compared with first 5 would be compared with 4, then 7 with 3. So as we have left side completely in this ascending form and right side in descending form, so it would be comparing, and at the end we would be getting in the left part all the elements would be smaller than all the elements in the righter part. So again after getting this part, we would call these two functions. That is, in Biotonic merge we would call the left side and the right side, which would further create a sequence which would be in ascending form. We can clearly see here like 1 9 3 4, and when we are calling see here we are getting a function 1 3 4 9 for the left part, that which is clearly sorted. So same thing will happen with 5 7 8 2, and at the end we would be getting our sorted array, that is 1 3 2 3 4 5 7 8 9.
The pseudocode of Biotonic sort. Here you can see that this is the pseudocode of Biotonic merge. Before the pseudocode, we need to know about the Biotonic sequence. Biotonic sequence is basically a sequence that first increases and then decreases, or vice versa. It forms a mountain-like structure which will have a Biotonic point. The element to the left of Biotonic point are arranged in ascending order, and to the right are in descending order. Now in the Biotonic merge pseudocode, you can see we have 4 parameters. The first one is array, which represents the array we need to sort. And load represents the starting index. CNT is basically the count, that represents the number of elements to process. And dir is the sorting direction, which is true for ascending and false for descending. The process goes like this. The array is split into 2 halves. Recursively, we sort the first half in ascending order and the second half in descending order. Then these 2 halves are merged into a single Biotonic sequence using Biotonic merge. Now you can see the now here is the time complexity analysis of Biotonic sort. The first, we have 2 approaches here. The first one is sequential, and the second one is parallel implementation. For sequential implementation, we will have time complexity of big O of n log square n, because the algorithm works in log n stages, and each stages perform comparison and swap, which require big O of n log n. Similarly, for parallel implementation, we have big O of log square n, because since multiple steps can be processed in parallel, which reduces the number of steps. So you can see that time complexity is much better than the sequential approach. So talking about the space complexity, here also we have 2 approaches. The first one is recursive, which will have space complexity of big O of n, because obviously we will be using recursion stack space. Similarly, for iterative, we will have constant space complexity,